Hello and welcome. Today's video lecture will focus on certainty equivalent value, utility, and probability. We'll begin to understand these concepts through an example. The example reads, a person has the following utility function for income. U equals 8 times m to the 1/2, where u represents utility and m represents income. What is the amount of utility that the person gets from $500,000? So first, let's define utility. What is it? So in economics, utility is a measure of satisfaction. How much satisfaction does a person get, in this case, from $50,000? So to answer this question, I will take $50,000 and plug it in for m in this position. So here's our original equation, and now let's substitute m for $50,000, and this is our answer. The person gets 1788.85 units of satisfaction when they have $50,000. Next, let's move on to Part B. Part B states, suppose the person is facing a bet. The bet is a coin toss, so there's a 50% chance of winning and a 50% chance of losing. And the bet is $5,000, so the person either wins $5,000 and ends up with $55,000 or loses $5,000 and ends up with $45,000. What is the expected utility of the bet? So let's begin by defining some terms. Expected value. So the expected value is the expected net dollar from taking the bet. It is how much money the individual expects to walk away with if they take the bet. The next concept to define is expected utility. So expected utility is the net expected satisfaction from taking the bet. How much satisfaction does this individual expect to have if they take the bet? Now, let's examine how to calculate expected value and expected utility. The formula for expected value is to sum the probabilities times net amount. For example, this individual is taking a bet that is a coin toss. So the probability of winning is 50%, and there's a 50% chance that they lose. The net amount they end with if they win is $55,000, and the net amount they end with if they lose is $45,000. So applying this formula, probability times net amount, I can sum them to get the expected value. So in this case, the expected value of the bet is $50,000. Now let's look at expected utility. Again, it is a sum equation, where we will sum the probabilities times net utility, for example. Note here is our utility function, which we use to find the net utilities from taking and not taking the bet. So here we have, if we win, there's a 50% chance that we win. We'll move here, that we win, and that we end up with $55,000. We plug in that into our utility function to convert it to utils. Now the same thing for our loss. There's a 50% chance that we lose, and if we lose, we end up with a net of $45,000. We plug this value into our utility equation to convert to utils. Summing these values, we get an expected utility of 1786. Let's move on to Part C. Part C asks, what is the certainty equivalent value of that utility? In other words, what amount of certain income would give the same utility as expected from taking the bet? Again, before we jump into this problem, let's define some terms. So what is a certainty equivalent value? A certainty equivalent value is a dollar amount that will give the individual the same utility as taking the bet. So now let's go back to the question. We have to find a dollar amount that is equal to the amount of utility of taking a bet. So in other words, if we take a dollar amount and convert it to util terms, it should equal the utility of taking the bet. So let's put the CEV into util terms. To do so, we will use this equation. U equals 8 times m to the 1/2, where we're going to replace u with the utility of taking the bet and solve for m, which will be our CEV. So let's set up our equation. Here, we have utility of taking the bet, and we set it equal to this value. After that, we will solve for m, and m represents the CEV. It is the dollar amount that is equivalent to the utility the individual gets when taking the bet, this value here. So basically what we did was we converted a util term into a dollar term. Let's move on to the next part of the problem. This section states, now suppose the person is facing a different bet. The same coin toss, but now the bet is $20,000. So you either win $20,000 or pay $20,000 from your $50,000 earning. In other words, the person will either end up with $70,000 or $30,000. This question asks us, what is the expected utility of the bet, and what is the certainty equivalent value? So again, here is the formula for expected utility. We will sum the probabilities times net utility. Note, here's our utility function, which we will use to convert our net earnings into utility. Given, we have this equation. 0.5, there's a 50% chance that we lose, and we end up with $30,000. We'll take this $30,000, plug it into our utility function, and convert it to utils. We add that to the probability of winning. There's a 50% chance that we win, and if we win, we end up with $70,000. Again, we must convert that to util terms, so we plug $70,000 in the m position of this equation. When we sum those two values, we get an expected utility of 1751.12. If the individual takes this bet, they're expected to end up with 1751 units of satisfaction. Next, we must find certainty equivalent value. Again, remember, certainty equivalent value is a dollar amount that is equivalent to the amount of utility the individual will get from taking the bet. In other words, it is the amount of money you could give to an individual that will convince them not to take the bet. So to solve this, we set up this equation. The utility of the certainty equivalent value must equal the utility of taking the bet. So we know that the individual gets this many units of satisfaction when they take the bet, and we must convert that to a dollar amount. To do so, we will use this equation, which ties together utility and m, a dollar amount. So we substitute this value for utility and solve for m. In this case, m is $47,912. If you recall, in the previous bet, the CEV was higher at $49,874. So in other words, when the individual is taking a smaller bet, they required more money to convince them not to take the bet. This encapsulates the concept of risk inversion. Individuals don't want risk, and the more risk found, the more money they will take to compensate for the utility escaped from that risk. That is all for this tutorial. Thank you for watching.